Hello students, welcome back to JCE Connect. In this particular lecture, I'll be solving one design example of a simple slab base plate. That is design of simple slab base plate for the column. So in previous lecture, we have been discussed about the design procedure of base plate for the column. So we have discussed 7 steps how to design base plate step by step. We have been discussed following those steps. So in this design problem, so let us take the design example as design the base plate for an ISHB 350 column to carry a factored load of 1500 kilonewton. Assume Fe 410 grade steel and M25 grade concrete. Also design concrete base. Take SBCF soil as 150 kilonewton per meter square. So this is the problem given, and column section also mentioned here. For this column carrying a load of 1500 kilonewton, that is factored load, and this column is resting over a concrete pedestal of M25 grade concrete, and then concrete pedestal resting over the soil, and that soil SBC is also given. So for this column we need to design the base plate. As we know, the function of base plate is just to distribute the load coming on the column over the concrete pedestal. Hence the stresses can be minimized. So that is the function of the base plate. So what size of base plate is required for this column carrying a load of 1500 kilonewton? The question. So the design, you need to follow the steps given earlier. The steps are, that is the first step we need to follow is calculate the strength of concrete, which is given by 0.6 FCK as per the IS 800 2007. So here I have written the step number 1, calculate the bearing strength of the concrete. We need to calculate first the bearing strength of the concrete. The bearing strength of the concrete is 0.6 FCK. So this is the formula given in IS 800 2007. You can write here as a reference IS 800 2007. So in this code, this formula has been given. The bearing strength of the concrete should not exceed 0.6 FCK. So we need to take 0.6 FCK, and as for IS 456 2000, the bearing pressure for concrete will be 0.45 FCK. But since it is a steel structure resting over the concrete pedestal, it is given maximum as 0.6 FCK. So FCK is the characteristic strength of concrete for 28 days of curing. So here M25 grade of concrete is given. So I have taken 25 characteristic strength. Then we get the bearing strength of the concrete as 15 Newton per millimeter square. That much is the permissible in the concrete. Then after calculating the first step, that is the bearing strength of a concrete, let us calculate area required for the base slab. Calculate the required cross section area of slab base. Area required will be what? Load by bearing strength of the concrete. That is, load means the factored load coming on the column, PU. Bearing strength of the concrete already calculated. Then 1500 divided by 15. So we get the area 1 lakh millimeter square. Then after calculating area, so let us take the properties of the given section. The ISHB 350 at 710.2 Newton per meter. So for this section you have to get the properties, that is I section you have to refer. And from the steel table you have to take the properties of I section. So just to refer the IS, that is ISHB 350 is given. Search ISHB 350. So here it is given ISHB 350. ISHB, there are two sections given here, ISHB 350, ISHB 350, but the weight per meter differs. Here this weight is 661.2 Newton per meter, and this one is 710.2 Newton per meter, but I am taking this one. So in design problem, if if the two sections are present in a steel table, then the weight per meter will be differs. So here 710.2 Newton per meter, this section I am taking. Then from this you will get what is the depth of the section, what is the width of the flange, thickness of the flange section, then thickness of the web. All you will get from the steel table. So refer steel table and take the properties. Here I have taken ISHP 350 710.2 Newton per meter. One more section is available, that is having 661.2 Newton per meter. Okay, so if nothing is mentioned, only ISHP 350 is mentioned, you may take any one. Either you can take 710.2 Newton per meter weight, or you can take 661.2 Newton per meter, and corresponding section properties to be taken. Here the thickness of the flange I have taken 11.6 and thickness of the web is 10.1. High depth of the section is 350, then the width is 250 mm. So this is the section. So this will represent the depth, width of the flange, thickness of the web, and thickness of the flange. So you have noted down all the properties of the section. Then so that section, whatever the section given, you place over the base plate. That is width of the base plate as a B and length as a L. So still we don't know these dimensions L and B. Just you place the section over the plate and just mark the depth and width of the flange. Then projections also you mark like this. Now let us calculate what is the length here. So I can write the length will be, so length of plate will be what, 350 plus 2b, 350 plus b plus b. Then width of the plate will be what, 250 plus 2a. Still we don't know the projection A and B. A and B are the projection. Now area will be what, length of the plate into width of the plate. Then length of the plate can be written 350 plus 2b, one term. Then 350 plus 2b, 250 plus 2a, another term. Then this is the area. Now provide the same projections. Now I can write this area. We know the area will be how much, 1 lakh is equal to 350 plus 2b into 250 plus 2a. So provide same projections, that is A equal to B. Now I will get this will be 1 lakh is equal to 350 plus 2a, one term, then 250 plus 2a. Now if we simplify this one, I'll get 8,500 plus 700a plus 500a plus 4a square is equal to 1 lakh. This I get equation. Further you simplify, you'll get 4a square plus 1200a minus 12,500 is equal to 0. Okay. Now solve this quadratic equation. If you solve, use calci. If you solve this equation, you can use this one equation, then degree 2. If I substitute the coefficient of a 4, then 1200, then minus 12,500, so I'll get x, that is a, as 10 millimeter projection. But the code says the minimum projection, but minimum projection should be 50 mm. Therefore provide A equal to B equal to 50 mm. Now I can write LP will be 350 plus 2B, that is 350 plus 2 into 50, you will get 450 millimeter, and width of the plate will be 250 plus 2A, that is 250 plus 2 into 50, you will get 350 millimeter. Therefore, provide base plate of size 450 by 350 mm. Now I got a base plate size of 450 by 350. Okay. So next, after calculating base plate size, so now calculate, so what is the actual bearing pressure acting? Actual bearing pressure acting. Now actual bearing pressure of concrete, you can call it as a W dash, that is 1500 divided by this one, then actual area 350, we get 9.52 Newton per millimeter square. So which is less than permissible? The permissible we have got 15 Newton per millimeter square in previous step. So this one. So we are having a permissible is 15, but after providing a base plate size, that is L into B as 450 by 350, we are having a bearing pressure of concrete as 9.52, which is less than the 15. It is not crossing the 15, hence safe. Hence it is safe. Now, so once we get the base plate size, the next step will be what? Calculation of thickness. Okay. This is step number 4. Step number 1, 2, then this will be step number, this is step number 3. This is step number 3. Then this is step number 4, we have calculated the actual bearing pressure of concrete. Then step number 5. So what is the step number 5? Calculate this one. Step number 5, calculate minimum thickness of slab base. Calculate minimum thickness of slab base. So for this you have to refer IS 800-2007 page number 47. You can write clause 7.4.3.1 IS 800-2007 page 47. So there the thickness formula is given as root of 2.5 W, that is W dash actual pressure to be taken, A square minus 0.3 B square, then gamma mu divided by Fy, then this should be greater than thickness of flange. Substitute all the values here. When you substitute all the values here, 2.5 into 9.52 into 50 square minus 0.3 into 50 square into 1.1 gamma divided by 250, you will get a thickness of plate as 13.53 millimeter, which is greater than thickness of flange, that is 11.6 mm. So hence you can provide approximately 14 mm. Hence provide a base plate of base plate of 450 by 350 by 14 mm. This is the size of the base plate. Okay, this is the size of the base plate. So after calculating the base plate, now for this base plate, you see this is the base plate size we have got. The length we have got as a 450 here, and width we have got 350 mm. So after getting the base plate size, so you have to weld this base plate here. You have to do the welding here in this. So the welding is required here, here. Here welding is required. Now we have to calculate what is how much length of weld is required. Okay. So after this one, next will be step number 6. Design of weld. So design of weld. So for this design of weld, assume size of weld. You can assume the size of weld, that is S equal to 8 mm. Then the thickness will be 0.7 S. So we get thickness equal to 0.7 into 8. You will get thickness as 5.6 mm. Okay, so this is thickness of weld. Then length available for welding along the periphery of the column. So here this is the column section we are having, this one like this. Okay, this is the column. Now this one is 350, this is 250. Now the length available for welding along the periphery of the column, along the periphery of the column. How much is length available? That you have to calculate. LW equal to, the length available is 2 into 250, means this side and this side is available. 2 into 250 plus 2 into 250 minus 10.1. 2 into 250 minus 10.1 here. Then plus 2 into 350 minus 2 into 11.6. See this 2 into 250 means here and here. 250 minus 10.1. This web is 10.1. The flange is 11.6. 250 minus 10.1. This side you get here inside. Mark here. First you have to weld here. This is 2 into 250 here, this side. Then here if you want to weld, so 250 minus 10.1, and this side 250 minus 10, that was 2. The next, here you have to weld. This is the length available for us to do the weld. 350 minus 11.6. 2 into 350 minus, that is 2 into 11.6. This side 11.6, this side 11.6. Okay. Then the length available will be, so you'll get length available 1633.4 mm. This much is the length available for us. Now we have to calculate whether this length is sufficient or not. Now the required length of weld. Required length of weld. How much is the length required? So the required length of the weld can be calculated. Load divided by strength of weld per millimeter run. Load divided by whatever the load is coming, then we calculate strength of weld per millimeter run. We get the required load. Then what is the strength per millimeter run? It is strength of weld per millimeter run. So we know the formula, Fu divided by root 3 gamma mw into length of into thickness. Fu will be taken 410 divided by root 3 into 1 point, you can take it as a 1.25 or 1.5. I'll take a side welding into length is 1 and 5.6. So you get, I'll calculate this one, 410 into 5.6 divided by root 3 into 1.5. So 883.73 Newton per millimeter. Then calculate required length required. Load is 1500 into 10 raised to 3 Newton divided by 883.73. You will get 1697.35 millimeter. So which is greater than length of weld available. Okay. So available length of the weld is this much is available for us. So if you do the welding all around the section, only this much is available for us if we calculate. But the length for this load, whatever the load is coming, that is this much of load is coming on the column, but the length required will be 1697, but which is greater than. So now we have to revise the size of the weld. So hence, since, you can write one line, since length of the weld required is more than length of the weld available, hence revise the size of the weld. You have to revise the size of the weld. Take size of the weld as 10 mm. Therefore thickness will be 0.7 as you will get 0.7 into 10. You will be getting thickness 7 mm. Now required length of the weld. Length of weld required, you will get 1500 into 10 raised to 3 divided by strength of weld per millimeter run, that is 410 divided by root 3 into 1.5 into 1 into thickness as 7. Once again you have to revise the size of the weld. Then after this you will be getting 1357.88 millimeter, which is less than length of weld available, hence safe. Okay. But lastly, anchor bolts. Anchor bolts you need to provide. So provide 24 mm 24 mm dia anchor bolts on 4 sides of the corner. So in this you have to provide 24 mm dia. Just you have to write one line. In this one you have to provide here 1, 2, 3 and 4. So on all the 4 corners you have to do the anchoring, that is anchor bolts to be provided. Just you need to write one line, provide 24 mm dia bolts and the anchor bolts on 4 sides of the corner. Okay. Then lastly we need to design the size of the pedestal, size of the pedestal required. Okay. So you need to design the size of the pedestal. That is step number 7 only. That is a concrete base design. So this one you have to take the working load to be taken. So working load, so this is 1500 divided by 1.5. The factor load is equal to 1500, but you need to take the working load for design of concrete pedestal, that is 1000 kilonewton. Because you cannot, since it is a factored load, the SBCF soil cannot be factored. So as it is to be taken, hence you need to take the, for working load only you have to design the concrete pedestal. Then self weight of footing. Next, self weight of footing to be taken 10% of column load. 10% of column load. So whatever the column load is coming, the 10% of the 1000 into 0.1, you will get 100 kilonewton as a self weight. Then total load on concrete base. Take total load on a concrete base, that is 1000 plus 100, you will get 1100 kilonewton, the load coming on the concrete base. Then the area of concrete base required. Area of concrete base required, that is total load divided by SBC of soil. The total load is 1100 into 10 raised to 3 divided by SBC of soil is given as 150. Then the area required is 7.33 meters square. This is 150 Newton per meter square. So you will get kilometer per meter square. You will get this much of area. The next, provide square base. Provide a square base, then we get length equal to breadth equal to root of 7.33. So this much area we required. Since we are providing a square base, then L equal to B equal to 7.33, you will be getting 2.7 meter. Therefore provide concrete base size as 2.7 meter by 2.7 meter. But we need to calculate what is the depth of pedestal required. Next, depth of pedestal required. To calculate the depth of pedestal required, next, depth of pedestal required. So here this is the concrete pedestal. This is a concrete pedestal. On this concrete pedestal, this is the base plate. So on this base plate, this is the I section provided, like this I section, and here the anchor bolts are provided. Okay, now this one we have calculated now, that is length and breadth. So this is 2.7 meter and this is also 2.7 meter. We have calculated this one. Now we have to calculate the depth for the concrete.